Hello students, welcome to EPG Pathshala. I am Dr. Hemant Sharma from MIT University, Haryana. Today we are going to talk on module decision analysis with probabilities. Expected value approach under the paper quantitative techniques for management decisions. Dear students, it is very important module because after studying this module, you would be able to understand how to structure the decision problems. Second, you would be able to decide or take the right decision under risks when probabilities of occurrence of different states are known to you. And third important benefit that you are likely to gain from this module is how to develop a suitable decision strategy under the given circumstances. So dear students, first of all you need to understand the meaning of the decision making. As we all know that decision making is an integral part of any business organization. Everyone, every manager working on the middle level or the top level is likely to take some decisions. Some decisions can be very important decisions. Some decisions can be routine decisions. But important thing is in decision making what we do. Whenever we are to take a decision, we usually have two or more than two choices or alternatives, and every alternative has a particular or multiple outcomes. So, suitability of any alternative obviously depends upon the outcome of that alternative. So, if we are having the knowledge of the outcome of every alternative, so we can go with that particular alternative that is going to maximize our profits or minimize our losses. And most important thing about the decision making is whenever we are trying to take decision, obviously we want to take a good decision, a correct decision. So for that, the prerequisite is that we must be able to include all possibilities, all positive and negatives pertaining to every choice in our decision problem. So it is very important for you to understand. So as far as decision theory under risk is concerned, so as we have already studied in the previous model, then that decision maker while taking decision usually has two or more alternatives to choose from, and he always tries to take the best decisions. And decision theory under risk, it provides an orderly way of choosing among several alternative strategies when decisions are made under risk. While taking a decision, risk exists when decision maker is not knowing with certainty the outcome, but the probabilities of various outcomes can be stated by him on the basis of either previous records or the judgment or the experience of the decision maker, which are known as objective probability or subjective probability. Now I would be explaining to all of you the decision theory under risk, what process it actually follows. So whenever a decision maker is to take a decision under risk, he essentially needs to pass through a process in a fixed sequence that can be described as a sequential process. At number one, he must be able to identify all possible outcomes. Second, he must be able to identify all possible strategies, yeah, or alternatives. Third, he must be able to assign a probability value to every outcome based on certain criteria. If he is using the previous records, he is taking the help of the previous records. So that means he is trying to assign the probability value objectively, and if he assigns the probability value on the basis of his experience or knowledge, so it's known as the subjective probability. Now there are two criterias which are usually used by the decision maker when he has to take decision under risk. The number one is the maximum likelihood principle, and second is the expectation principle. So I would be discussing both, but here one important thing is to note that decision maker has no control over the outcomes. Whenever you need to take a decision, what would be the outcomes of that decision, you are not knowing in advance. Second important thing, the decision maker has control over the strategies. Which strategies to be used in a particular decision, it can be controlled by the decision makers. And next important thing is, all outcomes must be mutually exclusive. It means not any two outcomes must occur together, and collectively exhaustive. It means we must consider all possible outcomes. If I explain it to you with the help of a simple example, when I throw a dice that has 6 faces, 1, 2, 3, 4, 5, 6, if I throw a dice, the result would be either 1 or 2 or 3 or 4 or 5 or 6. So here 2 and 3 cannot occur together. Any two number cannot occur together. It means all outcomes are mutually exclusive in case of the dice. And second important thing, all possible outcomes are 6. 1, 2, 3, 4, 5, 6. It means all outcomes are collectively exhaustive. There is not any other outcome of this particular strategy or course of action, that is throwing a dice. Now here it is important to note that sum of probabilities assigned to every outcome should be always equal to 1, and it is only because of the fact that we we assume that we have considered all possible outcomes of that of that particular decision. Now we will try to understand the maximum likelihood principle and expectation principle, which are used in the decision making under risk by the decision maker. So dear students, it's a very simple principle, maximum likelihood principle. In this, decision maker will simply consider the payoffs of the strategies or the course of actions which are corresponding to the highest probability value. So in this simplest sense, what I can say, that first of all, every outcome is assigned a probability value. It can be objectively assigned or it can be subjectively assigned. So once we have assigned a probability value to each and every outcome, now we will see the corresponding payoff value for each and every alternative course of action, and we will select the course of action that has the maximum payoff corresponding to the highest probability value. I would be explaining it next, but here what is the important thing to note, that in this case we are simply ignoring all other probability values, all other outcomes with the lesser probability values. We are not considering the contribution of the outcome with the lesser probability values. We consider the contribution only of the outcome that has the maximum probability of occurrence. Similarly, in expectation principle, again very commonly used principle, in this decision makers with the outcome probability assigned, it can be objectively assigned probability or it can be subjectively assigned probability, as the case may be, the expected payoff for each alternative is calculated by multiplying the payoff value with their respective probabilities and then taking sum of these products. this strategy, the strategy with the highest payoff is finally selected. So it looks better than the maximum likelihood principle, because here we are taking the contribution of every possible outcome, whether the possibility can be lesser or can be higher for any particular outcome, but still here we are considering the contribution of each and every possible outcome in finding out the best strategy or the optimum strategy. It's a very important topic for the students to understand Bayesian decision rule, that is also considered as the posterior analysis. This is an extension of the previously discussed criteria. In this, optimal strategy is selected on the basis of the revised probabilities. First, the previous probabilities are revised in the view of some new information obtained from the marketing research or sampling test, and then we calculate the expected payoff of different strategies with the help of the revised probabilities, and obviously the strategy that is giving the maximum value of the payoff is finally selected. So dear students, as I have discussed with you that whenever a decision maker has to make decision under uncertainty, he is not aware of the probabilities of the various outcomes. So there he can take decision using the different criterion, and the next stage is when he has to take decision under risk. Under risk means he is well aware of the various outcomes of the different alternatives or strategies, and moreover he can also assign a probability value to every outcome. So if it happens in any decision making, that decision making is said to be decision under risk. So decision theory under risk provides an orderly way of choosing among several alternative strategies when decisions are made under risk. So students, now by so far you must have understood that risk exists when the decision maker is not knowing with certainty the state of nature or the outcome. But the probabilities of various outcomes can be stated on the basis of past records or the judgment of the decision makers. So, if he is assigning the probability value to any of the outcomes on the basis of the previous record, it is known as objective probability, and if he does it on the basis of his experience or knowledge, then it is known as the subjective probability. So now we will understand the decision making under risk with the help of the example which I have considered in the previous module. The same example of bread packet where retailer has to select the best alternative in view of the given outcomes. Best alternative means that is going to maximize his profits or going to minimize his total costs. So here we have mainly two principles to select the best alternative. The first one is maximum likelihood principle, and second principle is expectation principle. So with the help of this example, first I would be explaining you the maximum likelihood principle. So dear students, in this table you can see that we are given with the different outcomes, that is demand for bread packets 80, 81, 82, 83, 84, like that, and the various alternatives A1, A2, A3, A4 up to A5. We are also given with the probability value corresponding to every possible outcome. So here you can observe that for outcome 80, when outcome is equal to 80 packet, the probability is 0.05. When outcome is equal to 81 packet, probability is 0.10. When outcome is 84 packets, the probability is 0.10. So we know the value of probability for every possible outcome. Now, to select the best course of action, we consider the maximum likelihood principle. Maximum likelihood principle, as I have already stated, that decision maker first considers the outcome that is most likely to occur, or I can say the outcome corresponding to the highest probability. He then decides the alternative that has the maximum conditional payoff corresponding to this outcome. So in this example, what we do, first we will see the highest probability value. So it is obviously corresponding to outcome 83, and this highest probability value is equal to 0.40. So now what we will do, we will evaluate every alternative course of action against this probability value. So for alternative A1, the value of payoff corresponding to this probability value is 240. For strategy A2, value of payoff corresponding to this value of probability is 243. For strategy A3, value of expected payoff is 246 corresponding to the highest value of the probability, and similarly for strategy A5, the value of highest expected payoff is equal to 240, and it is corresponding to the highest probability value. So out of these values, the highest expected value is obviously 249, and it occurs corresponding to strategy A4. So obviously, as per the maximum likelihood principle, we will go with the strategy A4. So students, it's very easy to understand with the help of this slide that maximum likelihood principle, it considers only the highest value of probability or the most probable occurring outcome. It simply ignores the other outcomes or the contribution of the other outcomes in deciding the most suitable alternative course of action. So it may be considered as the main drawback of the maximum likelihood principle. Otherwise, this principle is very good as far as the calculation of the best alternative is concerned. It is very easy to solve, very easy to do. Now, I have already discussed that here the highest probability value is for demand 83. So strategy A4 is the best one as per the maximum likelihood principle. So here I have mentioned the strategy A3. So you are requested to make it correct. The highest value of the payoff is rupees 249, that occurs corresponding to strategy A4 instead of A3. Dear students, the second important principle is the expectation principle. Again, it is very simple to understand. In this, as I have already explained, that decision maker with the outcome probability assigned, whether it has been assigned objectively or subjectively as the case may be, the expected payoffs for each alternative is calculated by multiplying the payoff values with their respective probabilities and then summing up these products. The strategy with the highest payoff is finally selected. So we try to understand this principle with the help of the given slide. So in this slide, the same setup as in the previous case, we have different demands that are equal to the possible outcomes, and we have different alternatives A1, A2, A3 up to A5. Now we are also given with the probability values corresponding to every possible outcome. So here, as per the expectation principle, what we are doing, we are calculating the total expected value of every alternative or strategy by multiplying the expected payoff by the corresponding probability value. So, for example, in this case, we can understand that for alternative A1, the expected payoff is finally rupees 40, and for strategy A2, expected payoff are equal to rupees 242.5, for strategy A3 equal to 244, and finally for strategy A5 expected payoff are 236. So if you wish to understand the calculation of getting the expected payoff, we can understand it with the help of the strategy A3. When retailer is placing an order for 82 packets, so when demand is 80 and strategy is A3, so we can see the probability value is 0.05 and expected payoff 226. So we will multiply it 0.05 multiplied by the 226 plus 0.10 multiplied by 236 plus 0.35 multiplied by 246 plus 0.40 multiplied by 246 plus 0.10 multiplied by 246. Now, if we take the sum of all these products, it would be equal to 244. So, in this way, we have calculated the expected payoff for all possible alternatives, and in this case, maximum value of payoff is 24 and its corresponding strategy is A3. So, maximum value 244 occurs corresponding to strategy A3. So, A3 is the best suitable strategy according to the expectation principle, that is maximizing the profits of the decision maker. Now, one important thing we can notice here, that expectation principle is including all the values of the probabilities. Unlike the maximum likelihood principle, it considers all probability values to calculate the expected payouts corresponding to the every strategy. So it is not ignoring the contribution of the other possible outcomes apart from the outcome with the highest probability. It considers the contribution of all possible outcomes to arrive at the expected payoff of every strategy. So it is certainly, what I personally believe, better than the maximum likelihood principle. Yes, it is slightly difficult compared to the maximum likelihood principle as far as the calculation part is concerned. So comparison of both criteria. So students, I have already told you that maximum likelihood principle is considering only the payoff corresponding to the highest probability value, and expectation principle considers the contribution of each and every outcome. It is ignoring the probable value of every outcome. So on this parameter we can compare both the criterions, but as far as the ease of calculation is concerned, it is certainly better to go with the maximum likelihood principle, but for the better results we must go with the expectation principle. Regret table. So this principle, expectation principle, can also be used when we are given with the costs or when we are given with the opportunity loss. So in this slide you can see that we have prepared an opportunity loss table, a regret table, and with the help of this table we can calculate the expected regret value against every alternative, and we can find out the minimum value of the regret and the corresponding strategy would be the best strategy. So in this case, we can easily understand that 3.2 is the minimum value of the regret and its corresponding strategy is the A3. So A3 is the best strategy as far as the best suitable strategy is concerned. Now we will talk about the expected payoff of perfect information. Now here, what I want to tell you that suppose retailer knows in advance that what would be the next day demand and he knows it with the certainty. How will he order accordingly? Obviously, if he knows that the next day demand would be 80 packets, he will certainly order 80 packets, thereby maximizing his profits to rupees 240 because profit per packet is rupees 3. So profit on 80 packets would be rupees 240. And if he is knowing in advance that the next day demand would be 81 packets, so in that case he will certainly order 81 packets, thereby increasing his profits to rupees 243. So in this way you can see the expected profit of the retailers if you are also given with the probability value. So probable value of the profit would be rupees 12 in case of the market demand is for 80 packets. In case of demand of 81 packets, the probability value is 0.10 and the expected profit would be rupees 24.3. So in this way we can calculate the total expected profit, that is equal to rupees 247.2, and this amount is equal to the highest profits if retailer knows with certainty the demand for the next day. Now here what we observe that retailers maximum expected profit in absence of the advance information is equal to rupees 244. So if you see the payoff table for the same example, you will see the highest payoff value is rupees 244. So total expected profit when retailer has the exact information, that is equal to rupees 247.2, and in the absence of the exact information the highest payoff is rupees 244. So obviously the worth of advance information is equal to 247.2 minus 244 equal to rupees 3.2. So the worth of this advance information is rupees 3.2 and it is equal to the least expected regret value. So if you see the regret table, you see the least value of the regret, so it is equal to the 3.2. So it is very important piece of information for the students. So you need to go with this concept in depth. So students, now I am going to discuss with you very important decision rule that is known as Bayesian decision rule. It is also known as posterior analysis. So students, this is a criterion that is ignoring the prior values of the probabilities and it advises to go with the posterior probabilities. Actually, Bayesian rule is an extension of the previously discussed criteria. According to this, optimal strategy is selected on the basis of the expected payoff criterion, while the expected payoffs are calculated using posterior probabilities. Prior probabilities from past data are revised using the additional information that are obtained from marketing research or sample testing. Use of posterior probabilities facilitate better decision making. This will be explained with the help of the following example as mentioned in the slide in front of you. So in this slide you can see that there is a tire manufacturer who is in process of taking a decision pertaining to use of three types of the raw materials A, B and C to make tires. The management feels that overall acceptance of its tires would be either high or low in the market. the payoffs expected under different combinations of combination outcomes and strategies along with estimated probabilities are given below. So in this table you can see there are two outcomes, high acceptance and low acceptance, and the probability of high acceptance is 0.3, low acceptance equal to 0.7, and you are also given with the payoffs for different strategies or different types of the materials. So for material A, in case of high acceptance, the payoffs would be equal to 4 lakhs. For material B, in case of high acceptance, payoffs would be equal to 2,40,000. For material C, in case of high acceptance, the payoffs would be equal to 1,15,000. So in this way, you can see the payoffs for the high acceptance and the low acceptance. So from the above information, management has two options. First, take decision pertaining to the material on the basis of the prior information only, as we have done previously. Secondly, conduct a market research and then using the prior information and additional information to take this decision. So here you see the prior analysis. This analysis has been done using the previous methods. So here you can see that for both outcomes we can calculate the expected payoffs for strategy S1, for strategy S2, for strategy S3. So value of highest payoff is rupees 1,14,000 and its corresponding strategy would be S2. It means the manufacturer is advised to use the material B while manufacturing the tire. Now we wish to improve this decision making. Now I would be using the maximum expected payoff as I have calculated just now. Now in case of high acceptance, the highest payoff is rupees 4 lakh. You can see in the given data. That is obviously for material A. And for low acceptance, the highest payoff is rupees 95,000. That is for strategy 3 or material C. So thus we can calculate the expected payoff of perfect information as below. So in the table, you can see that for high acceptance, probability value is 0.3, highest payoffs are 4 lakhs. So expected payoff would be 1,20,000. So in case of low acceptance, you can see the expected payoffs 66,500. So total expected payoff equal to 1,86,500. So the expected value of perfect information can be calculated as 1,86,500 minus 1,14,000 equal to 72,500. So if we are having the perfect information, obviously we can increase our payoffs by the 72,500. Otherwise, we will have to compromise with the expected payoff equal to 1,14,000 only. Now we will go with the Bayesian decision rule, that is also known as posterior analysis. Now we will include the additional information which is also known as indicator obtained from a market research or any other mean in our decision making to improve our decision. Assume that outcome of a market research can be M1, that represents a favorable report pointing out a satisfactorily high acceptance of the users, M2, that represents an unfavorable market report indicating an unsatisfactory and low response. So using above information, now we wish to compute revised estimates of the outcomes in order to revise our decisions based on prior probabilities. As market report would not always be 100% correct due to prevailing uncertainties, therefore, to make an effective use of this report, we must know the probability relationship between indicators M1 and M2 and the outcomes E1 and E2. On the basis of the past records of similar research, we can see estimates of the relevant or conditional probabilities in the table. So in this table, you can see the conditional probabilities, and this table can be obtained only by the previous related research made by the market agencies or research agencies. So here, what is the meaning of conditional probabilities? For example, 0.80. 0.80 represents the probability of getting a favorable report when the true state of nature turns out to be a high acceptance, that is equal to E1. Symbolically, we can represent a value of probability M1 upon E1 is equal to 0.80. It means when actual outcome is even, the report would be favorable 80% of time, and 20% time it is supposed to be unfavorable. Similarly, a conditional probability 0.05 shows the probability of getting a favorable report when the true outcome turns out to be low acceptance, that is equal to E2. It means when true outcome turns out to be E2, the report would be 95% times would be unfavorable. So with the help of the conditional probabilities, now we can move for the revised probabilities. You can see that we have two possibilities. Number one, we may have a favorable market report. Number two, we may have an unfavorable market report. So first I will go with the favorable market report, that is represented by the M1. So in this table you can see we have two outcomes, E1, E2, prior probability 0.3, 0.7 given to us, conditional probability from the previous related study of the marketing agency or research agency 0.8, 0.05. We can calculate the joint probability 0.3 multiplied by 0.8 is equal to 0.24. Similarly for E2. Now we can calculate the total probability by taking the sum of both the probabilities. Now in the last column you can see the calculation of the posterior probability. So for outcome E1, the posterior probability would be equal to joint probability divided by the total probability. So it is equal to 0.872. For outcome E2, it is equal to 0.127. So if market report is in fact favorable one, then we will use the posterior probabilities in place of the prior probabilities to find out most suitable strategy. You can see that in case of high acceptance outcome, now I will go with the posterior probability which have been calculated just as previous, 0.872 and 0.127. Now I am given with the expected payoffs for the different strategies. So here I can calculate the expected payoffs for all possible strategies, and the highest value of the payoff, expected payoff, is 3,42,450. So from the above information, we can see the highest expected payoff is for strategy S1, or I can say he is advised to use the material A, and thus we can conclude that given that a favorable market report is obtained, the optimal strategy would be S1, and the corresponding expected payoffs would be rupees 3,42,450. Now I can also get an unfavorable market report that is represented by the M2. So in that case, I can calculate the posterior probability like the previous one. For outcome E1, it comes to be 0.0827. For outcome E2, it comes to be 0.9172, and the total probability is 0.727. It means that if market report is in fact unfavorable one, then we will use the posterior probabilities in place of prior probabilities to find out most suitable strategy. So now we can make the use of the posterior probabilities, which are also known as the revised probabilities. So in case of the high acceptance, the revised probability is 0.08. For low acceptance, the revised probability is 0.91. Now, using posterior probabilities, we can calculate the expected payoffs for all three strategies, and expected payoff is maximum for the strategy S3. So we can go with the strategy S3. Now, it's obvious from the above information that highest expected payoff is for strategy S3. It means manufacturer is advised to go with the material C. Thus, we can conclude that given that an unfavorable market report is obtained, the optimum strategy would be S3. So we can note that when a favorable market report is obtained, the maximum expected payoff would be rupees 3,42,450 and optimal strategy S1. When an unfavorable report is obtained, the maximum expected payoff would be rupees 96,217 and optimal strategy would be S3. But these decisions are conditional because we can take them only if we are knowing the report in advance. As there is a probability of 0.275 for the report to be favorable and 0.725 to be unfavorable, we can get the expected payoffs as shown in the table. So in this table you can see when market report is favorable, M1 probability is 0.275. For M2 state, the probability is 0.725. So conditional payoff of the best strategy in case of M1 given to you, in case of M2 96,217, and expected value for M1, expected value when report is not favorable, you can calculate. Now total expected payoff 1,63,931.075. So this is the expected payoff of the optimal decision, and it is important to note here that this decision is based on the revised probability. So students, at the end of this model, we can sum up that decision making under risk is very important, and it is very complex thing for the decision makers, because if he is not knowing the probability of each and every outcome with the you know with the correctness, so in that case he has to go with the subjective probabilities. So assigning the subjective probability needs a lot of experience, lot of knowledge of that particular decision, and here the decision maker is playing a very important role, because his main responsibility here is how to give a probability value to different outcomes. So as far as calculation is concerned, so here calculation is very easy, because mainly we have only two criteria: maximum likelihood and expectation principle, to decide upon the best strategy. So if we see the computational part of decision making under risk, that is very easy to understand for the students. Thank you.